Today we're going to talk about something called the extreme value theorem. So the extreme value theorem, as you see right here, if f of x is continuous, and that's very important, on the closed interval a,b, then f of x has both an absolute maximum and an absolute minimum on a,b, and you're going to find those either at the critical values on the interval or at the endpoints. So let's talk about what this means, and then we'll get into some examples. So if you have a function that's continuous, and you set the interval, okay, so it's not from infinity, but you just pick a specific values. So here, if I'm just looking from -3 to +3, in that area, we have an absolute maximum and we have an absolute minimum. And what the mean value theorem says is those are going to happen either at a critical point, like here and here, or at the end points, like here and here. So it's always over a closed set. It's not infinite. It's over a specific set of values. So what we're going to have to do when we are trying to find the absolute max and absolute min is we're going to evaluate at the endpoints, get those values, find where there are critical values, where the derivative is 0, and then evaluate the function at those points. The biggest of those will be the maximum, the smallest of those will be the minimum. So let's do an example. We have the function 2x cubed minus 15x squared plus 36 on the restricted domain 1, 7. So the first thing we're going to do is investigate the endpoints. So we're going to evaluate our function at 1. So when x is 1, okay, and you can use your calculator to help you here, but we get a y value of 23. Okay, we're going to do the same thing at 7. This one will give us a value of -13. So those are both candidates for the absolute max and absolute min, but then we also need to see if there's any critical points, any maximums or minimums that are bigger in between 1 and 7. So to find the critical values, we're going to take the derivative. So this is going to be 6x squared minus 30x. We're going to set that equal to 0. And I'll factor out my biggest common factor. So 6x times x minus 5. So the critical values of the function are when x is equal to 0 and when x is equal to 5. But we only care about the ones between 1 and 7. So even though 0 is a critical value of this cubic function, we don't care because it's not between 1 and 7. So the only critical values that we care about is 5. So now we'll evaluate the function at 5. And we get a value of -89. Okay, so we have 3 candidates for the extreme values. We have 23, the -13, and the -89. So the largest value is going to be the 23. So that is the absolute maximum of this function over the restricted domain 1, 7. The smallest value is the -89. Now we can graph it on the calculator to confirm this. So we'll plug the function in. So 2x cubed minus 15x squared plus 36. For our window, my x's we want from 1 to 7. Our y's, we know the biggest is going to be 23, the smallest is going to be negative 89. So let's go negative 100 for our minimum, let's say 30 for our maximum. And if we graph it, there's our maximum, there's our minimum, and it matches what we found analytically. So here's our next one. It is going to continue on to the next page of your notes. So our function is 6x to the 4/3 minus 3x to the 1/3, and our range is -1 to 1. So we're going to evaluate at the endpoints. So we're going to have 6 times -1 to the 4/3 minus 3 times -1 to the 1/3. This is going to make this a positive one, or positive, so that's 6. This will be negative, which will make that positive. So we get 9. At 1, we're going to have 6 times 1 to the 4/3 minus 3 times 1 to the 1/3. 1 to anything is the 1, so this is just 6 minus 3, which is 3. Now we'll take the derivative to find the critical values. So our derivative will multiply 4/3 times 6, so that's going to be 24/3 x. We'll subtract 1, which is going to be 3/3, so this will be to the 1/3, minus 3 times 1/3 is just 1, x to the 1/3 minus 1 is a -2/3. So to find the critical values, we're gonna factor. Let me simplify this first. We're gonna pull out the least power, which is gonna be the -2/3. So we're gonna pull out an x to the -2/3, which is gonna leave me with 8. We're gonna subtract the exponent that we just pulled out here. So 1/3 minus a -2/3 is 3/3. So this is just an x minus 1. So my critical values are going to be 0 and 1/8. Both of those are in our range. And 0, the derivative is undefined at 0, but the function is defined at 0. So this still counts as a critical point. Now we're going to evaluate at the critical points. So f of 0 is just going to be 0. Okay, and f of 1/8, you can just use your calculator. We get a -1.125. You certainly could do this by hand, but we won't. The absolute maximum, so the 4 values that we're looking at are the values at the endpoints and the values at the critical points. So the biggest of all of those is 9. The smallest of all of those is -1.125. All right, so we'll graph to confirm. So 6x to the 4/3 minus 3x to the 1/3. Our window, again, is pretty easy because we know our x's are going to go from -1 to 1. My y's, the biggest y I have is 9. My smallest is -1.25. So let's go from maybe -2 to 10 and graph. So kind of an unusual graph, but here we see our maximum value and our minimum value that we discovered. All right, so just different types of functions. So here we have x squared plus x all raised to the 2/3 power. So we'll plug it in at the endpoints, and you can just use your calculator for this, but f of -2, we're going to get 1.587. F of 3, we're going to get 5.241. For For the critical points, we'll take the derivative. To the negative 1/3 times the derivative of the inside, so that's going to be 2x plus 1. So we'll put this all together. So we're going to have a 2 on the top. This is all going to be in the denominator because of that. So we're going to have 2 times 2x plus 1 all over 3 times x squared plus x to the 1/3. And then here I'll factor. So we're going to have 3 times, in parentheses, x times x plus 1 to the 1/3. So my critical values are the things that are going to make this 0 or undefined. So the values that make the numerator 0 or the denominator 0. So that's going to be a negative 1/2. In the denominator, that's going to be a 0 and a negative 1. Check to make sure they're in the range, and all three of those are between negative 2 and 3. So we need to evaluate at all of them. So f of negative 1/2, f of 0, f of negative 1. Using the calculator again, we get a 0.397. F of 0 is 0, and f of negative 1 is 0. So looking at our candidates, the endpoints and the critical points, the biggest value is 5.241. The minimum value is 0. And then again, you can graph it using the information here. So again, just different types of functions. So we have 2 secant of x minus tangent of x on the range from 0 to pi over 4. So for the endpoints, and if you're looking at my homework answers, I just do EP for endpoints and CP for critical points. My endpoints, f of 0 is going to be 2 secant of 0 minus tangent of 0. Cosine is 1 at 0, so secant is also 1. Tangent is 0, so we get 2. F of pi over 4, we're going to have 2 secant pi over 4 minus tangent pi over 4. So cosine of pi over 4 is root 2 over 2. The reciprocal of that is root 2. So we'll have 2 root 2 minus tangent of pi over 4 is 1. That's great, but numerically, is this bigger or smaller? So if you just type that in the calculator, you're going to get 1.828, which gives us a better feel. So right now we've got 1.82. For the critical points, we need to take the derivative. So the derivative of secant is secant of x tangent of x minus the derivative of tangent, which is secant squared x. So I can factor out a secant of x, which leaves me with a 2 tangent of x minus a secant of x. So either we want secant of x to equal 0, or 2 tangent x minus secant of x equals 0. So here, secant of x is never equal to 0. And you can graph it to see that. But secant of x is always, since cosine is always between negative 1 and 1, the reciprocal is either bigger than 1 or less than negative 1. Here we're looking at where 2 tangent of x is equal to secant of x. So let's turn this into sine and cosine because that's easier to think about. So we're looking for where 2 sine of x over cosine equals 1 over cosine. So we're looking really for where 2 sine x equals 1. So where sine of x equals 1/2. So where does sine of x equal to 1/2? Well, there's an infinite number of times, but the one we're interested in is the one between 0 and pi over 4, which happens to be at pi over 6. So then we want to evaluate the function at pi over 6, which is approximately 1.732. And you can do it using the unit circle, but again, to compare the values, you really want the decimal. So now we pick our winners. Our maximum value of our 3 candidates is 2. The minimum value is going to be the 1.732. For this next one, we have a piecewise function. First thing you want to investigate on a piecewise is whether or not it's continuous. So at the boundary, here, 2 times 1 minus 1 is going to be 1. If I plug in 1 into this, we're going to have a negative 1 plus 3, which is 2. So it is not continuous there, which means it's not differentiable there. So we will consider that one of the critical points. So we want to investigate endpoints and critical points. So the endpoints, our graph is going to start at negative 1 and end at 2. So the negative 1 we're going to evaluate in this function. So 2 times the negative 1 minus 1 is negative 3. For the other endpoint at 2, we plug it into that equation. So this is going to be a negative 4 plus 3, which is a negative 1. For the critical points, for x equals 1, because we said that's our one critical point because the derivative is not defined there, the function value f of 1 using here is going to be 2. For the derivative of f of x, we're going to have 2 between negative 1 and 1, and we're going to have a negative 2x from 1 to 2. We don't include the 1 because, again, it's not differentiable there, so the derivative is not defined. Well, this one is never 0. This one is 0 when x is 0. But 0 isn't between 1 and 2, so there's no critical points from the derivative. So we have all of our information and we pick our winner. So those are our candidates. For this one, my minimum is going to be negative 3. My maximum is going to be 2. For this question, we're going to find the values of p and q if f of x equals x squared plus px plus q and f of 2 equals 5 is an extreme value. So the extreme values on a closed interval will occur at the endpoints or at the critical point. So since 2 is not an endpoint, that means 2 is a critical point, which means on a continuous function like that, that means the derivative is going to be 0 at the point 2, 5. So I'm going to take the derivative. So this is going to be 2x plus p. The derivative is going to be 0 when my x value is 2. So that means my p is going to be a negative 4. I can use that and the original equation and this point to find the value of q. So 5 is going to equal 2 squared. We now know p minus 4 times 2 plus q. So 5 equals 4 minus 8 plus q. So 5 is negative 4 plus q. So q is 9. So in these types of problems, just always remember that you have a point, you have the function, and then just what information they're telling you and what you can use that for. So our next problem is a polar problem. So we're going to find the minimum value of the x-coordinate if r is 2 plus 2 cosine theta over the set interval 0 to pi. So x is going to be r cosine theta for this particular equation. That will be 2 plus 2 cosine theta. So we want to plug in the endpoints. So for the endpoints, 2 plus 2 cosine, we'll do 0 times cosine of 0. Cosine of 0 is 1, so this is going to be 2 plus 2 times 1 times 1. So 2 plus 2 is 4. Now we'll do pi. So 2 plus 2 cosine pi. Well, cosine of pi is negative 1. So this is going to be 2 minus 2 times a negative 1. So that's going to be 0. Now we're going to find the critical points. So we're going to take the derivative. So we're going to need to do the product rule here. So we're going to have the derivative of 2 plus 2 cosine times cosine plus the derivative of cosine times 2 plus 2 cosine So the derivative of this, derivative of 2 is 0, so we're going to have a negative 2 sine theta times cosine theta. This derivative is going to be a negative sine theta times 2 plus 2 cosine theta. So clean it up a little bit, and then we'll find our critical points. So this is going to be minus 2 sine theta, and then distribute here, minus 2 sine theta cosine theta. So this is a negative 4 sine theta cosine theta minus 2 sine theta. We can, move these to the other side of the equation to make it equal to positive. So this would be a positive, and I'm going to factor out the common factor here, which would be 2 sine theta, which would leave me with a 2 cosine theta plus 1. So again, making these each positive and then factoring. So either 2 sine theta equals 0, because we're setting our derivative equal to 0, or 2 cosine theta plus 1 equals 0. So sine equals 0 when theta equals 0. So we've already got that one taken care of. Between pi, it's also 0 at pi. Here we're looking at cosine of theta equal to a negative 1/2. So between 0 and pi, that's going to occur at 2 pi over 3. So that's our last candidate. So we'll plug that into the original x function. So 2 plus 2 cosine 2 pi over 3 cosine 2 pi over 3. Well, we know it's equal to negative 1/2. So we're going to have 2 times the negative 1/2 will be a negative 1 times the negative 1/2. So 1 times negative 1/2 is negative 1/2. So our minimum value of the x coordinate is going to be negative 1/2. Our next example, find the maximum value of the velocity of a particle if its position is this. So this is a little bit tricky. So reading is important. So we have a closed interval and we have the position, but I want to maximize velocity. So my velocity equation is going to be 3t squared minus 6t minus 9. So this is the function that we're investigating. So we're going to do the endpoints and the critical points of this. So for our endpoints, v of 0 is going to be negative 9. V of 2 is going to be 3 times 2 squared minus 6 times 2 minus 9. So 3 times 2 squared is 12 minus 12 minus 9 is also negative 9. So we're looking for the maximum value. So negative 9 is a candidate, but now we're going to see, is there a bigger value that occurs at the critical points? So we're going to take the derivative of velocity, which is going to be 6t minus 6, set that equal to 0, and we get t equals 1. So then we'll find what is v of 1. So 3 times 1 squared minus 6 times 1 minus 9. So we're going to have 3 minus 6 is negative 9. Minus 9 is negative 18, which is not bigger. So our maximum value is going to be negative 9. Just a quick 3 minus 6 is negative 3 minus, this is a negative 12. Still, negative 9 is our answer. The last question, if f is a continuous function on the closed interval ab, which of the following statements are not necessarily true? Well, if it's continuous on a closed interval, then it has a minimum and it has a maximum. Does f prime have to be 0? It does not. There's no information here that would say that somewhere there's a 0 derivative. We can have a continuous function that doesn't have a critical point. So 1 and 2 are those are the ones that are true. Not true is 3. So careful reading. 3 is not true. 1 and 2 are. So that is the extreme value theorem.